Thank you so much for joining me here in this session on streamlining large-scale Java development with Aeroprone. My name is Sander Mak. I'm from the Netherlands. I work with a company called Picnic, and we're an online grocery scale-up, and we deliver groceries with these cute electric vehicles in the Netherlands and also in Germany and France now. I'll tell a little bit more about what we do because it's important to know what we do to understand the tech that we need to build. But this session will be about Aeroprone. Now, I'm going to let you in on a dirty little secret of conference speakers. Because we, as speakers, we love to introduce new technology, right? We want to show you new frameworks, even new languages, new architectures. But the question is, what can you really take home from this, right? What can you start applying in your projects tomorrow? And the answer often is probably not that much. So what I want to do today is something different. I want to teach you a new superpower. And this is a superpower. Yes, we as developers can also have superpowers. A superpower that you can apply tomorrow already in your projects, that you can take away and use on any Java project that you have. So not a new language, not a new framework, but just a very small but powerful tool that you can add to your toolbox to make your life easier, especially if you work with large teams and have large code bases, as we will see. So what is this superpower, you ask? Well, this superpower is to be able to refactor and increase the quality and consistency of your code base at scale. And with that, I do not mean that I'm going to show you IntelliJ refactoring shortcuts and that I'm going to learn you how to do this faster and how people can do this frantically in their IDEs. No, I'm going to talk about this error-prone tool, which is something that you can apply as part of your development cycle, as part of your CI process, as part of your actual day-to-day work in your development practices. And it's all code. It is not something that you do with your IDE. And we'll see how it works later. But hopefully, this will inspire you to actually think about applying a tool like Aeroprone. There are more. But we at Picnic actually really love working with this tool and helping us shape our code bases. So a little bit about what we do. As I mentioned, we're an online grocery scale-up, and we want to tackle the online groceries challenge. That means that we want to make online grocery shopping fun, easy, and affordable for everyone. So we don't have stores. We only have an app where people can order, and we deliver those groceries. But we also have our own warehouses. We do our own order picking. We have these vehicles, as you saw, that need to be at the right place at the right time. So there's actually a lot of software that we have to build to make that happen. And not just the obvious app, of course, that needs to be built, but also everything that happens in the process around that. So we need to make sure that we have our own purchase orders handled. We need to make sure that our warehouses run smoothly, that our order pickers can work efficiently. And there are many, many processes here that need to support, that we need to support using tech. So in this case, if you look at this challenge, you can also put some numbers on this. We've started 7 years ago as a small startup, just in the Netherlands, in one city, doing this. But by now, we've grown quite a bit, and we're covering most of the Netherlands. We've started covering parts of Germany, and just started last year also in France with our business. And that means that we've also grown the tech team quite a lot. So when I joined in 2019, there were roughly 60 people in the tech team. Now, a bit over 2 years later, there's over 200 engineers. As you can imagine, a lot has happened in between, and a lot of code has been written by these engineers. And a lot of these people are new, right? So you're onboarding new people every month, and you need to somehow make sure that you create a code base that is consistent and maintainable also for the next 7 years or the next 20 years. So how do you do that? And that's something that we at Picnic tackle by using a lot of tooling, and one of these tools is Aeroprone, as I mentioned. So with this skill, we actually want to emphasize more and more the process around creating code. And one of the other tools that people think about a lot when they think about code quality is, for example, SonarQube. And this is also a tool that we use. It's a great tool. But it's also a bit hard to really consistently apply, right? Because you have this nice metric, you see some trends, which is great, but at the same time, it tells you you have like 10 days of technical debt or 20 days of technical debt. And what does it actually mean, right? And what does it actually, how does it actually help you to improve there? So there's some value in this tool, but it's mostly about getting insight and not so much helping you in your day-to-day commit, let's say, increase of quality of your code base. So somehow we want to have automated sanity in our code bases. And knowing your code is step one. So SonarQube and similar tools are a great way to do that. But there's more, right? We also want, for example, to automatically check that things do not get worse. And we can, for example, use tools like spot bugs and checkstyle to do automated analysis and checking of code. But if you have that, then you still have a tool yelling at you. What if you could have a tool that actually helps you apply these best practices? And what if this tool was even extensible in a way where you could encode your own best practices and could do your own large-scale refactoring in code bases? And this is what Error-Prone, together with another project called Refaster, offers us. So in a sense, I'm not saying that these other tools are bad. They have their place. We also use those. But you can go a step further. And that's what we're going to look at today. So what is Error-Prone? When you look at it just bluntly from a code perspective, it is a Java compiler plugin. So can the Java compiler have plugins? Well, yes, it actually can have plugins. Not something that is very widely used, but in this instance, it is a very good use case to write a compiler plugin for these kind of tools. So the nice thing about this, of course, is that it can hook into the Java compiler directly. It is not a build tool plugin, so not a Maven plugin or a Gradle plugin or anything like that. You can hook it into any infrastructure as long as you can define a Java compiler plugin. And the cool thing about Error-Prone is that out of the box, it already provides you with a lot of checks for your code that run as part of the Java compilation step when you add this compiler plugin. So there are a couple of hundred predefined BugChecks that already give you a pretty wide range of automated checks that are applied and that are on by default. What is also really, really nice is that this tool, made by Google, supports both Java 8, 11, and also Java 17, which for us was also quite important because we migrated to Java 17 end of last year. So in that sense, it covers the wide range of all LTS Java versions at the moment. So that's pretty cool. And if you actually look at the Error-Prone side, there's an interesting endorsement there from Doug Lee, the guy who wrote the Java util concurrent libraries, where he says, okay, well, it's a bit embarrassing. I guess I'm back to liking Error-Prone because it found a bug in the concurrent hash map implementation that he wrote. Though it sometimes annoys me, and I think we can all recognize the sentiment, right? These tools, they're very useful, but they can also be very, very annoying because they're so strict and they're always on and they're always sort of telling you what you're doing wrong, so that's not a great feeling, but in the end, we all know it's for the better. So that's at a high level what Error-Prone is. It is a Java compiler plugin that increases the sort of checks that are applied to your Java code that you're writing. But that's still a little bit similar to what you probably already know from other tools. So I'm going to give a little demo instead of talking about Error-Prone further and show you what it exactly means in practice. So what I have here is a very, very small class called MyBuggyApp. And there's an issue with this code. There's actually multiple, but probably one might jump out at you. Does anyone see what is wrong with this code? Exactly, we're creating an exception, but we're not throwing it. It just says new illegal argument exception. Now, this is perfectly fine Java code, right? It will compile and it will run. It's just not doing what we want it to do, right? Or what you would expect it to do in the most regular cases. So what you can do in the, let's say, first step of adopting Error-Prone is that you can add it to your Java compiler configuration. In this case, I'm going to add it in my Maven POM file, and I'm going to insert this little snippet here, where we add to the compiler args the Error-Prone plugin. And where does it get the plugin from? Well, it gets it from the annotation processor path, which we configure to have a dependency on Error-Prone core. And we also need to set the compile policy of the Java compiler to simple, because Error-Prone makes certain assumptions about the abstract syntax tree of the compiler that we're working with. If you add this simple strategy, then it will work as expected. There's a JDK bug open at the moment to make sure that this is not necessary anymore, but that is something that has not been fixed yet. So for now, you'll need to deal with that. But by adding this simple compiler plugin to your Java compiler configuration, we can actually run the same build again. and you will see that it actually gives a compile error, right? So it points to this line, and it says that exception. There was an exception created but not thrown. So this is an example of a predefined bug check that is already part of error prone. The nice thing is that the error is actually very much contextualized. As you can see, it gives you a suggestion. It says, did you mean throw new illegal argument exception? So the exact code that we have here, but only fixed with having a throw statement in front of it. And that's pretty cool, right? That is very specific and already helps you in fixing this code. But you might also think, well, if the tool, if this error-prone tool actually knows the fix, could it also apply this fix for me? And the answer there is yes. And I'm going to show you how to do that as well. So if we are going to instruct error-prone to do fixing rather than just signaling errors, we need to insert a little bit of configuration, telling it to patch here, which adds the EP patch checks flag, where we need to define, okay, which of the predefined bug checks do we actually want to use for patching, and the patch location. So I'm doing in-place patching now, so we'll just update the source code as we see it in the IDE. You can also provide a directory here, and it will output patch files that you can apply separately if you want to. But the point is, it can generate a diff and it can apply it for you to fix the error that is found in the code. So now, if we run the same build again, you will see that it does not give an error, but it actually succeeds. And if we go back to this code, it has been fixed automatically. That's pretty cool, right? So we have a tool that not only detects a bug pattern, but it can also fix it for us. So I think that's a really, really powerful thing to have in your toolbox. And like I said, there are a couple of hundred predefined checks already for you to use that you can use out of the box when using the error-prone compiler plugin. And many of those also are able to actually fix your code and help you with that. So I think all in all, this should already give you a pretty good impression of what error-prone looks like. But it doesn't end there. So you can think of error-prone using patching like sort of an autocorrect for your code, right? But hopefully a bit more useful than the typical autocorrect on your phone. And if you look at error-prone and the predefined bug patterns that are there, we now saw one that was just a core Java pattern, right? Where we had a that exception that was not thrown. But it's not just about core Java. There are also checks in there that are pretty specific to some frameworks and to some libraries that we use often in our code. So there's some Android-specific checks because, well, it's a Google project, so obviously they have some Android-specific checks in there. But there's also JUnit checks. If you forget something in annotation pointing to a parameterized method, it can help you find that. And there's some more. There's even Joda-time checks. So there are lots of things from the wider ecosystem included in these error-prone checks as well that you get out of the box by using error-prone. If you start using this tool, you may see a lot of errors or warnings, and you may or may not agree with them. So there are a couple of things that you can do. So on the one hand, by adding these flags, these XEP flags, you can actually tune the severity. So you can turn errors into warnings or into info level kind of things that you want to see in your build. But you can also turn some of these checks off. And you might want to do that maybe temporarily as you're introducing this tool and you need to fix up code before you want to go all in. That might be one reason. And another reason might be efficiency. So we, for example, disable the Android checks because we're checking backend code. So we don't want to have these Android patterns in there using up CPU cycles. So that's something that you can disable as well. And the other thing that you can do is you can also in code suppress these checks if you want to. And you can do this using the same mechanism that you also use to suppress the regular Java compiler checks that are in there. And you can use the @suppress warnings annotation and then refer to the name of the check that you want to suppress. So if we wanted to suppress this error that we just saw, then we would have to annotate the main method with @suppress warnings, that exception, and then for that instance, it would not trigger this error. So for all intents and purposes, these checks that are run by error-prone very much behave as compiler warnings and as compiler errors. So that's really powerful that you can use the same sort of infrastructure and mechanism to manage those. So the suppress warnings one, yeah, you probably want to use these for exceptions where you do want to enable the check, but you have some places in your code where you actually say, okay, I'm okay with having this bug pattern in here. So this is sort of a high-level overview of the checks that it can apply for you, and also already showed a little demo of the patching that it can do. There are some more use cases as well, and there's one I want to highlight before we move on, and that is a var check that is in error-prone that you can use as well. So you probably all have this annoying coworker that says, we need to go fully immutable, right? Everything, it's easier to reason about, it's great, you won't have any threading issues anymore, and you know they're right, but at the same point, it also feels very, very awkward to start adding final everywhere, right? On your parameters in your methods and in your local variables. So what if you could sort of flip the defaults around, where you could assume that every variable, every local variable, every parameter is final, unless you annotate it with add var. And that's something that error-prone also supports. So this add var annotation you can then use to indicate any local variables that should be mutable. And if you don't have a add var annotation on a local variable and you try to reassign, so use it as a mutable variable, then actually error-prone will give a compiler error because, well, it's still a compiler plugin. It can check this for you at compile time. And we use this in our code bases, so we are effectively assuming everything is final. If you want to opt out from that, then you need to use this ugly add var annotation, and you need to sort of make sure that you really need a mutable variable there. And in practice, this turns out pretty well. We do have some add var annotations in our code base where it makes sense, but in a lot of places, this can be prevented, and you don't have to apply the final keyword everywhere in your code base. So that's pretty nice as well. It's not a bug pattern per se, but it shows the power of having such a compiler plugin with these kind of checks and how far they can go. The interesting thing is that these bug checks that we saw so far, they all come out of the box if you use this error-prone plugin that I've just shown. But there's actually a whole ecosystem around this where you can also add additional jars to your annotation processor path containing other checks provided by the community. So for example, from the Mockito side, there's a Mockito error-prone contribution which checks for some Mockito-specific anti-patterns that you can hook into your compilation step. There's also a contribution from the community around slf for J usage. So there are lots of things that you can tap into to make the tool even more useful. And I think that's really nice. So it's in that sense pretty modular. You can add more of these checks as you use more libraries, more different things from the ecosystem. But it also raises the question, right? If these organizations can provide these kind of checks, would it be actually possible for you yourself to also define these kind of bug checks? And the answer there is yes. And I'm going to show you how that is done. And for that, I'm going to introduce a second Maven project called My BugChecker plugin. And what we want to do is we want to write a simple bug check, a simple error-prone bug check that tries to find methods that are empty, that have an empty body, because, well, we probably don't want to have those, and that might be an error. So we are going to write this empty method checker as an extension of the BugChecker class in error-prone in My BugChecker plugin, the project. And then once we have that available as a jar in our local Maven repository, we're going to hook that into the error-prone installation that we already had in the Buggy app that we just saw. And we are going to use that. So we are going to add the My BugChecker plugin to the annotation processor path. And then through service loading, error-prone will discover this additional bug check that we can then use and apply to our code base. Oh, there we go. So I first want to show you the POM file of this second project that I talked about, the BugChecker project. It is actually quite straightforward. We have, again, the Maven compiler plugin. In this case, we don't specify that we're going to run error-prone on this because we don't want to go full inception with checking on checks. But we do have an annotation processor that helps us with exposing the bug check as a service by using Google's auto service project, which is a very nice way to do this using an annotation. I'll show this in a bit. And we have these dependencies because we are going to write code against the error-prone API, right? If we want to write our own BugCheck. So that is the build side of things. Let's go to the code. So we have this empty method checker class, which extends BugChecker. We specifically say, okay, it's a method tree matcher because we want to look at methods. And before we write the actual implementation, let's make sure that this class can be discovered as a service. And we're going to expose this as a BugChecker for the service loading mechanism to be functioning. And we also need to annotate this with a bug pattern annotation, where we say, okay, the name of this check, and this is sort of the identifier, like that exception that we saw before, but we are going to call this one empty method. Here we go. And the summary is, we don't like do nothings. There we go. And we also need to specify a severity. So let's say this is an error because, well, we can. Let's just turn this into a compiler error. And now the sort of plumbing is done, and we are only interested in the logic, of course, of this BugCheck. And the error-prone BugChecker is much like a visitor, and we implement a method that visits methods. So we get a method tree that we can expect and some state that we're not going to use here because we are going to keep it simple. And what we can do now is say, okay, well, if this method tree that we get, if we get the body and we get the statements, and if there are no statements, if it's empty, then we want to return that something is up. So we're going to use the describe match method, which is part of the BugChecker class that we're extending, and saying, okay, we found something on this method tree, and we also want to offer a suggested fix, where we say, well, probably you might want to delete this part of the AST. And note that we're not talking about source lines of codes, etc. We're really talking about abstract syntax tree nodes, and the whole infrastructure of error-prone and the compiler around this will translate this into actual lines of code that need to be deleted if you want to apply this suggested fix. And if not, then we're going to return no match, and that should do the trick. Right, so this is fairly easy. It's also somewhat simplified because there might be some reason why you want to have an empty method. For example, if you need to override it and you don't want to do anything, we could write an exception for that, of course. But let's keep it simple and let's keep it like this for now. We're going to install this one to our local repository. There we go. So that we can use it in our buggy app project. I'm also going to copy the coordinates here so that we can use it directly. Now I'm going to go back to the buggy app that we just saw before. I'm going to go into the POM file and add an additional path to the annotation processor path configuration. And through the auto service and the service loading mechanism, it will hopefully find our BugCheck that we just wrote. There's one more thing that we need to do. We're also going to add the empty method check that we just created to the patch checks, because, well, then it will be picked up and it will hopefully also be applied. So let's get back here. As you can see, we have this empty do nothing method, and we are now going to run the Maven build again on this MyBuggy app, and poof, it's gone. I think this is really, really cool because we just created our very own BugCheck with our own pattern that we want to match. We, through the error-prone APIs, provided a suggested fix. We really didn't need to know too much about the details about what happens underneath. And by just providing this as a service and putting it in the annotation process path, we have our own refactoring that we can apply automatically and that we can do consistently across all of our code bases. So that is the way in which you can introduce your own kind of bug checks and bug patterns into error-prone. So just to give you a little bit of an idea of what we do, the kind of checks that we add fall into 3 categories. So first and foremost, we're also interested in enforcing correctness of the use of APIs, for example, in our code. So one example is that we have a check that actually verifies if you're using time handling code, that you're not assuming that the default time zone is the one to be used, but they're actually providing one, that you are using overloads that are specific about time zones. And for example, that you're not using things like local datetime.now, but that you're using actually an abstraction, like injecting a clock through Spring, for example, to actually get the current time so that you can easily test this and mock this, etc., etc. So these are things that you may have faced yourself as well, and often these come up in PR reviews, and there's countless debates, etc., etc. But the very nice thing is, once we have 3 or 4 PRs where such a discussion occurs, we actually go back to the drawing table and say, okay, can we write this into an error-prone bug check? And if so, then we do it, and then we can hook it into our build, and these discussions never need to happen anymore, because it will always be applied through this automated check that we just wrote, and that hooks into the Java compiler. So that's one area where we introduce our own checks. Another one is where some APIs are a bit prone to runtime errors or runtime problems. So an example of such a check that we've written is for SLF4J. And sometimes people, when they use SLF4J, you can use these placeholders, right? The curly braces works pretty well. But sometimes people are a bit confused and they start using the standard Java formatting placeholders like %s or something like that. This has actually happened quite a bit more than you would hope. And you can easily write a check that inspects these invocations to a SLF4J method, and then looks at the first parameter, inspects it a little bit, and sees if there are any stray non-compliant placeholders in there, and then give you a very nice error message. And the same thing for when you log a message and you have multiple placeholders, but you don't provide enough parameters. This is not something that the compiler statically checks, but by adding this check, we can do this during compile time anyway. So yeah, these are things in which we prevent developers from writing code that looks okay, but at runtime will produce the incorrect result, or might even break. Then there's style, of course. And yes, we also use check style, and we also use Google Java formatting and all these automated tools. But there are still things that are left over after these tools have done their magic that are often debated. And we want to reduce the amount of debate that we have on PRs on style, right? Because in the end, that's really not productive. Nobody's really helped with that. So if we can enforce these kind of style choices using error-prone, then we do that. An example is annotation syntax, where you might write in annotation value is, but yeah, you can also leave it out if it's just a single value that you're providing to the annotation. So we much prefer the one on the right-hand side here. And the same when you have an array-typed value in an annotation. You can actually, if you have a single element, also leave off the array braces and also the trailing comma. It's actually legal syntax, but pretty ugly, right? So we also want to prevent that. So these are all things that you can also inspect and check using such a bug check. So all in all, these 3 categories, they catch a lot of issues that would otherwise maybe slip past the PR review, but otherwise might take up valuable time during discussion of such a pull request. So, sounds pretty good, right? There's also some downsides. I deliberately just showed the top annotations of the bug checks, not the implementations, because, well, it's quite a bit of code that you need to write to actually implement these annotations, these bug checks that I just showed. Because the more complex your checks become, the harder it becomes to traverse the whole AST and keep the right state and make sure that you actually flag the right errors. So this is definitely not trivial code to write. We are fortunate that we have a platform team with some dedicated capacity to actually pick this up and work on this. And at our scale, that makes a lot of sense. But yeah, writing these custom checks can be tricky and can be daunting, especially if you want to emit good suggestions, where you need to be very, very deliberate about how you transform the old AST into the new AST that you want to suggest as a fix. So that is a little bit of a downside of using error-prone in this way. Now, what if we could take this even a step further, right? Because the idea of some of these checks is pretty simple. where we say, okay, we have this sort of pattern, it looks like this. So we have this before code, this old code, and we also know what the resulting code should look like in concrete syntax. So what if we could actually specify rules in this way? So rather than having to implement this BugCheck and traversing this AST and emitting suggested fixes, what if we could just, in concrete Java syntax, specify a anti-pattern and the correct code, and then have error-prone, and in this case, together with Refaster, do the magic. And that's actually possible. And I'm going to show an example of that as well. So with error-prone, you can also use a tool called Refaster. And what you can do with a Refaster template is do exactly what we just described. You can write some code that serves as a template or as a pattern to match in concrete Java syntax. You do this in a method that you annotate with add_before_template. And then you write an add_after_template annotation on top of another method that shows the right way to do it. And then by compiling this into a Refaster file using a special compiler that also is provided by the error-prone project, you will get a Refaster file output that can be used by error-prone, the compiler plugin that we already saw, to apply to your code, to apply to your code bases. So we're going to see an example of this. It's important to understand that the code that we write in this string is empty template class is actually never run. It's just used as input to create this .refaster file that is then used to apply this rewrite, this refactoring to other code. So in that sense, it's only there to instruct Refaster how to make the match and how to write the replacement code. And again, we're going to look at an example of how to do that. And for that, I'm going to my third project, which is just what we saw. And the idea here is that we want to rewrite a pattern where if somebody calls equals on a string and then compares it to the empty string, or if someone calls length on a string, then compares it to zero, we actually want to replace this with .isEmpty because it's more intention revealing, it's much nicer. And if we go back to our buggy app, you can actually see that there's an example here, right, where we look at the first argument by dereferencing this array element, which results in a string, and then on the string we call equals empty string. So this should be replaced by a call to .isEmpty by creating this Refaster template. So let's see how we can do that. So I've already written the before templates, and just to explain how this works, the idea here is that in the return value, you indicate what kind of expressions you're going to match. So we're going to match against any expression that results in a Boolean, because, well, in the end, the equals and the length comparison, they result in Booleans, as does the isEmpty method that we want to call later. But not just any expression, but expressions that are of a particular form. And this particular form is that there's some expression of type string. It doesn't have to be a literal string. It can be anything that is of type string that is in here. So in that way, the parameter that we define here is sort of the free variable in the template that we're trying to create, that we're trying to match. And then we say, okay, if then a .equals call with the literal empty string is put in there, then we have a match. Then we want to replace this with our resulting after template. And the same for equals, right? So we say, okay, if there's any expression of string and then at some point length is called and we compare it to 0, that's also something that we want to replace with our after template. So I'm going to add in here the after template. A nice trick here is that you can also apply this to the negation of these kind of expressions. That's also something that you can use pretty easily. And in the after template, we only have to write what we want to replace it with. Obviously, it needs to be of the same type because it still needs to compile. So this is also a Boolean expression that in the end is returned. And again, we don't really care about the expression that is in front of all this, but we do care about this is empty. That's the method that we want to put in the replacement code. So if we go to the POM file for this project, where we have this Refaster template, then you see that we, again, are using a compiler plugin, but this time it's a different plugin. It's the Refaster rule compiler, which turns this class that we just had into this .refaster file. And we have to also specify where we want to output this empty string.refaster file. So I'm doing this one level up, so I can use it easily in the other project. And of course, we still need to have error prone on the annotation processor path, so it can also locate this plugin. So if we're going to run this project and build this project, then what should happen is that it compiles a class, but that's really not the point. The point is that we also get this output file, this empty string.refaster file, that we can now use to automatically apply this rewrite in our buggy project. So let's go back there. And let me go to the POM file here. I'm going to replace this configuration with another snippet where we still have the EP patch checks, but instead of referring to the existing patch checks or the bug checks that we defined ourselves as classes, we're going to refer to a Refaster file, in this case the empty string Refaster file, that we can use to do this rewriting. And that should be enough to actually apply this. So let's find out. We're going to run the Maven build again. And there we go. Poof. It is now transformed into isEmpty. So that is a pretty nice way of also defining these kind of rewrite rules, right? So you don't have to traverse an AST manually anymore in the BugCheck implementation, but you can just write concrete Java code that you want to match and write concrete Java code that you want to emit as a replacement. And then under the hood, this is all translated by error prone into these AST manipulations and matching, etc., etc. But you don't really have to worry about that. You can easily do this in this kind of code. So can you only do expression rewriting? No, these Refaster templates can do more. You can also specify a sequence of statements that you want to rewrite into another sequence of statements. These do have to match structurally in this way. There's no real variability in the statements that can come in between. But here's an example of where we see a pattern where people are using a list. They're swapping elements in the list, and they're doing this in 3 statements, whereas you could also use the collections.swap method. And yeah, this kind of code is then replaced by this collections.swap statement. So you can do this on expressions, but also on these kind of blocks of statements. So what do we use this for? Well, one of the nice things is we try to move to newer versions of Java, newer versions of library pretty frequently. Like I said, we moved to Java 17 end of last year, so pretty much a quarter after it was released. But we also migrated to Java 11 pretty quickly. And the cool thing is, new Java versions means improved libraries, right? And improved ways of working with, for example, optional. Now, usually, the old way is also still available because, of course, Java is backward compatible, so you don't have to do this. But of course, it is nice to make use of these new libraries. Now, often people say, okay, we just do the Boy Scout rule, right? If you touch any code and you see something that might be improved, you just do it. But in the end, you end up with sort of a mix with old code that has been barely touched and is then still on the old APIs, etc. So why not use Refaster to also, when you move to a new Java version, start using the new and improved APIs there? And this is one example. So before Java 11, we didn't have an isEmpty method, an optional. We only had isPresent. So what you saw a lot is that people actually said, okay, if not optional isPresent, then do something. And you can in a much nicer way do this now with isEmpty. So you can use Refaster to do this rewriting for you by just having this very simple template where you match, okay, if you match not optional isPresent, then you replace it by the optional expression .isEmpty. Another one is working with streams and optionals. So also in Java 11, the optional got a stream method, which makes it nicer to flat map it over a stream of optionals and get out the values directly. Here you see also the use of refaster any-of, which is another way of applying multiple patterns that you can then, when any of these patterns match, it will be replaced by the after template. And you also see here that we also used this pattern not just with JDK APIs, but also with a Guava API that we also use in our code base. So you can also rewrite any code. It just doesn't have to be core Java. It can be any library that you use as part of these rewrite rules. So just to give a few more examples, we also use Reactor for reactive programming. Over time, you also find some anti-patterns in these kind of code bases. Then you can also use Refaster to rewrite those and create these kind of patterns for your code base to improve step by step. Last thing I want to show here, again, a rewrite where we have some Reactor code. It doesn't really matter if you don't know Reactor. It's more about the idea behind this rewrite. You can see that in the after template, we're calling toOptional, which is a static method, but it might not be imported in the code that you are adding this rewrite to. So you can also define an import policy when defining the after template, where in this case we say, okay, please add the static import for any code that requires it. And then this will also be automatically fixed by error-prone for you. So you don't have to worry about that, and your code will still compile. So yeah, that is pretty cool to see. When would you use Refaster, these Refaster templates? Well, if you have these migration patterns, right, of a previous version of way of working with an API to a new version of an API, we saw some examples from the JDK, we saw some examples also from the Reactor library, and especially if you have expressions which are fluent chains of invocations that need to be written to another pattern, Refaster templates are especially suited to that. It can also be pretty effectively used to migrate these consecutive statements, as we saw with the swap example. But these are more or less the use cases, and as you can see, it is somewhat more limited than what you can do with the BugChecks, right? Because there you had the whole visitor pattern, you had the whole AST at your disposal. You can go crazy. You can do a lot of complicated stuff, but it's harder to work with. So that's sort of the trade-off when you choose between these two tools. So we favor Refaster templates because they're easier to write, easier to maintain. But when we need to, we do write these BugCheck implementations as well. Refaster is also about refactoring, so rewriting code from one version to another. Whereas BugChecks, they can also be warnings, right? And they can also just, they don't necessarily have to give a suggested fix. So that's also a difference between these two approaches. Both have their place, and then, you need to choose based on the complexity what you actually need. If you go to the site of error-prone, they actually have some guidance as well on when to create a BugCheck. And if you want to create a BugCheck that's actually capable of being accepted into error-prone itself, then it should comply with all these criteria. It should be easy to understand. The fix should not be like a full page of code, but it should be just a small transformation. It should be easy to understand. It should have no false positives, and it should represent a correctness issue. As you saw some of the examples in the deck from how we use it at Picnic, not all of those are strictly correctness issues. There's also some style things in there. So we keep this to ourselves. But some of the, let's say, more generic checks, they're definitely possible to also make it into a more generic checking framework like error-prone itself. And in the end, what you want to evoke here is the emotion of, well, I'm glad error-prone caught this for me. That is sort of the reaction that you should strive for with all of the checks and the patterns that you apply and that you create. So how do we actually hook this into our CI pipeline, right? Because you saw local demos, it worked pretty nicely. But in the end, we need to do this at scale. So this means it needs to be part of our CI pipeline. And it's actually pretty straightforward. So in our builds, we enable the error-prone compiler, all the refaster, rewrite templates, etc. Then for each commit on a branch, on a PR, we run this build. And if this actually leads to changes, so if there's a non-empty git diff, then Danger, another tool that we use, will yell at you and say, okay, Well, apparently you have not run all the checks and patches yourself locally, so please do that before going further with this branch. So you cannot merge unless all of the rewrites have been applied and all the checks have been satisfied. Or you might add a suppression, of course, if you have some exception. But in general, yeah, every PR needs to conform to all of the checks and all of the rewrites that we have. So in that way, like I said, we have a platform team that is sort of guarding this set of these checks and these refactored templates. Other teams contribute, but in the end, it's rolled out to every repository, to every service that we build. And this helps us to create uniformity at scale. It also helps us to do large-scale refactorings, like I said. So one example is we, like I said, use Reactor. Before that, we used RxJava. These libraries are pretty similar in the APIs and operators they offer. So Refaster is a great way to migrate from RxJava to Reactor in this case. However, we did run into some limitations while doing this, because in the end, you start rewriting expressions, works fine, but at some point you reach the return statement of a method, and you're going to return a different type, because, well, Reactor just uses different types than RxJava. That's not something that Refaster supported. So what's, I think, pretty cool is that some people from our platform team actually got cracking at this problem and started creating an extension to Refaster, which also makes it possible to rewrite return types of methods, allowing us to migrate and to actually apply this at scale at our production code bases. And we even got a paper out of this at an academic conference, which is pretty cool. So again, yeah, a testament to the power of this kind of infrastructure that you can extend it in this way. So wrapping up, I hope you are convinced that this is actually a superpower that you can apply at scale when you have many teams writing lots of Java code. Just using error-prone stock out of the box already gives you a lot. And then the step to creating your own Refaster rewrite rules and your own bug checks hopefully is a bit lower and will give you a lot of leverage in terms of yeah, steering your teams and guiding your Java development in the way you would like to see it. I must admit, we do use a fork of error-prone at the moment. We've upstreamed a lot of changes already, but not all of them. Essentially, the fork that we have makes it easier to use a lot of these Refaster files together, whereas the stock error-prone implementation also just allows you to point at one at a time. Probably inside of Google's infrastructure, they fix this differently. But yeah, if you are going to use error-prone, consider using this fork if you are going to use a lot of the Refaster rules. And there are some other convenience tweaks in there as well. I want to point out, like I said, that we have people in our platform team who are pretty heavily into error-prone, also contributing there. If you have any in-depth questions ever about error-prone, feel free to reach out to Stefan Schroevers, who's our resident error-prone expert. He'd be happy to give you some in-depth details about error-prone and the inner workings of everything around it. And with that, I would like to thank you all for coming. I hope, again, that you want to apply the superpower yourself. Take this to your teams. And like I said, it is pretty easy. It's just a compiler plugin that you add, and you can reap a lot of benefits already. Also, if you like this kind of stuff, if you like working maybe in one of our platform teams, building this infrastructure and building it out further, I would love to hear from you. As we're, like I said, scaling pretty rapidly also on the tech side for Picnic, and not just in the Netherlands, but also Germany, France, many more countries to come. So yeah, feel free to reach out anytime. And if you have any questions, I'll be here, and you can ask anything you want. Thanks again, and have a great day.